Good evening, everyone. First, before going to our topic, I would like to introduce two words, metrology and meteorology. The two words that most of you may have confused. Meteorology is about weather and climate. Kalaguna Vidyawa. If we remove two letters from meteorology, the word becomes metrology. Metrology is about measurements. It is the subject of science of measurement. The definition of metrology is science of measurement and its applications. So today we are going to talk about this metrology. Today is a very special day for metrology. Today, May 20, is the World Metrology Day. So meteorologists, the scientists in metrology, celebrate World Metrology Day. As a meteorologist, I would like to thank SLASS Section E1 for organizing this webinar as a celebration of World Metrology Day. I'm Dr. G.W.C Wijayasundara from Faculty of Technology, University of Sri Jayawardenepura. So today, on this World Metrology Day, I would like to share some of my knowledge with you about the theme of the day, metrology in the digital era. Every year, BIPM introduces a theme with a poster designed by a National Metrology Institute. This year, the theme is metrology in the digital era. And this poster is designed by the National Metrology Institute of Ukraine with its regional metrology organization, UMIT. International Bureau of Weights and Measures, simply BIPM, is the home of the International System of Units, SI units. And it is also the home of the International Reference Time Scale, UTC. BIPM is established for the purpose of coordinating international science of measurement and for coordinating the development of the International System of Units, SI units. The Meter Convention is the treaty that created the BIPM. The Meter Convention is signed on May 20, 1875 in Paris by representatives of 17 nations. So World Metrology Day is an annual celebration of this incident, the birth of BIPM. At that time, only 17 nations signed the Meter Convention. But now, the most of all the countries have full membership or associate membership. Sri Lanka is also an associate member of this Meter Convention since 2007. The decision for the most recent development of SI unit is taken by BIPM on 16 November 2018. Member states of BIPM voted on that day to revise the SI units, changing the definition of the kilogram, the ampere, the Kelvin, and the mole. So all SI units are defined from 7 natural physical constants since May 20, 2019. This table shows those constants and their values. The digital transformation of all metrology processes can only be successful if they are based on SI-based digital data. Traceability means the ability to trace something. All the measurements should be traceable to the definition of the SI units. According to the SI definition, BIPM or developed National Metrology Institutes practically realize SI-based units. Other national metrology institutes calibrate their national standards from them. Accredited calibration laboratories calibrate their primary standards from these national metrology institutes. Measuring and testing equipment used in the industry get calibration services from accredited calibration laboratories. Like this, all the measurements in a country are traceable to SI units. Given by the BIPM through an unbroken chain of calibrations. This is the conventional way to maintain traceability through calibrations. However, maintaining traceability for measurements has become a challenge with the digitalization of industry and society. In Sri Lanka, Measurement Unit Standards and Services Department is the National Metrology Institute. So they are responsible for maintaining traceability of measurement in the country. Traceability is maintained through calibration. Calibration is a process establish a relationship between measurements of measurement standards and testing instruments. This is not the definition, but it is the basic idea of calibration. We can find a word called internal calibration in manuals of some of industrial instruments. Actually, it is a self-internal adjustment. So we should not be confused it with calibration. After calibration, we get a calibration certificate that shows indicator values of the testing instrument traceable to SI units through an unbroken chain of calibrations. The measurement values consist of quantity value, its unit, and associate uncertainty of the measurement. Verification. Verification is another word that can be confused with calibration. Verification is a process that assures that the instrument fulfills specified metrology requirements. After the verification, if the instrument fulfills the required specification, then the instrument will be sealed in a way that the instrument can't be adjusted to get fault indications. This photo shows the verification mark of a weight used for trade purposes. In here, crown is there because it is a symbol for another country, but in Sri Lanka, swan is used for as a symbol. In a country, legal metrology authority is responsible for safeguarding customers in commercial transactions based on measurements. So measurement unit standards and services department is also responsible for legal metrology from their act. When a measurement instrument is manufactured or assembled, if it is a new type, then it is for trade purposes, then manufacturer should go through a conformity assessment called type approval. All the weights, measures, and weighing and measuring instruments are verified before releasing to the market. So all the measuring instruments used for the trade should have at least an initial verification mark. After that, all those instruments are verified annually. Further, market surveillance done to prevent manipulative or illegal trading practices. So this is the practice most of all the countries use in legal metrology to safeguard the customers. However, digital transformation of society has become a challenge for legal metrology authorities to protect customers using these traditional methods. There are three main categories in metrology: scientific metrology, industrial metrology, and legal metrology. The main task of scientific metrology is the realization, establishment, maintenance, and dissemination of national measurement standards. National metrology institutes are responsible for that. However, with this digital transformation in industry and society, providing traceability for digital platform is a challenge for them, as I said before. For example, using intelligent sensors requires suitable traceability for both the physical properties of the transducer and the integrated digital pre-processing of the measurement data. Thus, with drastic challenges because of digital transformation, it is required the digital transformation for the entire traceability chain as well. So some National Metrology Institute has upgraded their services to keep the pace with the industry. For example, PTB, the National Metrology Institute of Germany, provides a reference architecture for manufacturers. The reference architecture ensures compliance with the required security standards. It is also ensures the ability for verification. The development of the architecture of a measuring instrument into legal relevant part and a free part allows the manufacturers to develop innovative solution in the free part of the software without going through the patent approval process again. PTB also offers the automated testing of algorithms based on reference data of them. They provide this kind of services for certain tasks in coordinate metrology. Predictive maintenance. Predictive maintenance is a concept used in industry with digitalization. In predictive maintenance, statistical analysis of the data can be used to draw conclusions about how reliable the system can be. By developing appropriate statistical modeling methods, it would be possible to establish continuous pre-diagnosis. This is usually done using model-free data analysis procedures. This is the concept behind the predictive maintenance. This guarantees the quality of measurement accuracy of the entire measurement system. This prevents unnecessary shutdowns of the facilities as well. Another interesting topic that metrologists work on is digital calibration certificate. A digital calibration certificate is not only the electronic document acting as a counterpart to the current hard copy. Actually, it is a virtual representation of the information which is relevant for the calibration certificate. For example, the data relevant to the calibration must be available in such a format that they can be read and processed automatically by another machine. If a secure and standardized digital calibration certificate is developed, when an additional sensor or measuring instrument adds to the existing measurement system, the control software of the system adapts it automatically in the way plug and play, based on the information given in the digital calibration certificate. This figure shows what is a fully digitalized life cycle of the network instrument could look like in the future. The blue circle represents the Internet of Things. It is the place where data is stored in a secure cloud. The dark blue blocks in the center represent the smart measuring instrument. The digital representation of the physical instrument is the relevant data of the instrument throughout its lifetime. The red color boxes represent the digital representation of the smart measuring instrument. So in here, we can see manufacturer, certification bodies, accreditation body, and inspection and verification authority, and also market surveillance. So these market surveillance, verification body are responsible for legal metrology side. And other two pillars in national quality infrastructure is accreditation body and the certification body. The life cycle of an instrument starts with the manufacturer. Manufacturer is responsible for the production of the measuring instrument, its remote control, its remote maintenance, as well as continuous analysis of data. The manufacturer can have marked the smart instrument electronically. For example, with the digital plate. The certification body is responsible for the peer assessment of the manufacturer's quality system for production. In the future, the authority for conformity assessment can remotely access the new type of measuring instrument. The certificate of conformity assessment, or in other words, the type approval certificate, may be stored in the smart instrument electronically. The test report of the type approval can also be stored in the same manner. Market Surveillance Authority will perform remote supervision and will remotely ensure conformity. The initial verification and the periodic re-verification will also be done remotely. After the verification, electronic or digital mark is stored in the digital representation of the instrument. The accreditation bodies are responsible for the accreditation of manufacturers, the certification body, and test laboratories. They can also remotely access to the instrument. In the digital transformation, we talked about 4 kinds of digital representations: digital plate, digital certificate of conformity, digital test report, and digital verification mark. These digital representation provide machine-readable interfaces. As this data is often used for legal actions, for example, in legal courts, all these digital representation have digital significance. So the information must be protected against unauthorized changes, including hacker attacks. Legal metrology is for the protection of customers. So during the digital transformation of legal metrology, it is essential to transform the national metrology law. So the first task is to develop the technical platform. After that, changes to the national metrology law can be done. It is necessary to ensure the legal significance of the digital representations stored in the digital cloud. Actually, this is a vision and not yet a reality. But many metrologists are working hard to make this vision become true in the not so far distant future. With this future outlook, I will finish this webinar. Happy Metrology Day for all of you. Thank you very much for your attention.